What's going on, everybody? It's Mr. Gus, and I'm back in the physics classroom. Today, we are still talking about energy, but today we're going to be talking about spring energy. We're still using work to describe our motion. We're using work to help us define different types of energy. We've done kinetic energy already. If you haven't done kinetic energy, go back, watch the kinetic energy lab, do the Wally lab, and figure out how we used work to find kinetic energy. Today, though, we're going to use work to figure out how to find the energy stored in a spring. Now, springs are weird. If I think about a spring, this is a spring. Right now, the spring doesn't have much energy. It's not going to move. It doesn't have potential to move. So in order to get a spring to start to move, I need to stretch it. And as I stretch it, I need to pull in the opposite direction of what we call equilibrium. I pull away from there, and I start to feel the force of the spring. So if I'm thinking about how I can find spring forces or spring energy or how a spring works, what I have to consider is that in order to pull the spring apart, if I'm going to pull with this hand, I need to pull in this direction. So I'm applying force this way, and as I pull this way, the spring is actually pointed back this way. So the spring is going to pull opposite my direction of motion. Let's go ahead and draw a picture of the forces applied to the spring. If I think about initially, or let's say at point A, here is my spring, and it's not stretched at all. It's at what we call its natural length. At point B, I have stretched the spring to a location further. I've stretched it from here to here, and we call this the displacement of the spring, or delta x. It's how far I have stretched it. And I would say in order to stretch it, I have to apply a force. And that force over this distance is what we would call the work done by the force of me, right? This is going to be now equal to the spring energy stored in the spring. U is an example of a variable that we use for potential energy. Work is change in energy. Kinetic energy is K. Any kind of potential energy, we typically use the variable U in physics to indicate this is energy not of motion, but energy that can result in motion. It is potential energy. It has the potential to do motion, to make things move. We also have gravitational potential. We'll use G for gravitational potential energy, okay? So with this understanding of as the spring is stretched, it's stretched because of a force. It's stretched over a distance. I should be thinking to myself, hey, I can use my work equation, force and displacement, force and distance, to figure out how much energy is put in the spring, how much work is done on the spring and stored up in the spring. So if I look at my equation today in this specific lab, we're going to say that this force times distance, this work done, is also equal to spring energy. And in order for us to figure out this relationship between force and distance and figure out what the equation for spring energy is, we're going to have to find the relationship between force of the spring, the distance we stretched that spring, and eventually graph, to figure out our equation, the displacement of the spring and the force of the spring. Now, I'm not going to graph this for you, but I will take some data with you. I will help you take some data in case you missed the lab, or in case your data was just absolute garbage in class. We will go ahead and do this. So if I'm going to go ahead and find spring force, I'm going to need some kind of device that measures forces. And so I've got, in fact, here a spring scale. Oh yeah, I'm using a spring scale to measure the force of a spring. I wonder how this thing works. Probably pretty similar to this. I need to also measure distance or displacement. In order to do that, I've got my meter stick right here. All we're going to do is stretch this spring and figure out how much force is on the spring, or how much force it takes to stretch this spring, a certain distance. So at home, go ahead and you can record your data. I'll try and keep up on the whiteboard up here. I am going to start it, and I'm just going to stretch this thing in increments of 5 centimeters or 0.05 meters. So I'm going to go ahead and write that down here, right? 0.05, 0.10, 0.15, 0.20, 0.25, and lastly 0.30. I'm going to stretch this thing 1, 2, 3, 4, 5, 6 times. 6 times I'm stretching it. You go ahead and record the forces associated with these displacements. Again, displacement is not the length of the spring. It is just how far I stretch the spring. That's the displacement I'm going to measure. Let's go. As you see right now, the length of my spring is roughly, let's call it 27 centimeters is the length of my spring. So as I go and I move this from 5, 10, 15, 20, I'm going to be going, it'll be the next 2 centimeters and the next 7, 2, 7, 2, 7. So I'm going to move that way. All right, here we go. I'm going to attach my spring scale right here, make sure I can make sure it's zeroed. It's at 0. And then I'm going to go ahead and stretch from 0 over here. Let's go ahead and stretch it from 27 to 32. And that first measurement is going to be 2.8. 2.8 newtons. 2.8 newtons is the first force for 5 centimeters. If I'm going to 10 centimeters, that force is now 3.9. 3.9 newtons. Let's go to, that was 5, 10, 15. At 15 centimeters, I have a 5.1. 5.1 newtons. Now we're going to 20. At 20, I see 6.2. 6.2 newtons. At 25. At 25, I see 7.3. 7.3 newtons. And lastly, my last data point here, my last data point for this is going to be at 30 centimeters. I'm going all the way from 27 to 57. This last data point, if I can hold it steady, is 8.8. 8.8. Let me double check to make sure I did that right, because I can tell based on my data that it seems a little out of sorts. I want to go from 27 to 57. I see 8 point. I did read it wrong. It's 8.24, 6, 8.6. I misread the lines. 8.6 newtons. All right, folks. That's the lab. If you missed class, that's all you missed. That's all we did in class. Pull a spring, measure it. Now, we did it twice. If you missed class, that's fine. Do it once. Graph some data. Once you graph your data, you're going to analyze the slope using units. You'll analyze the area using units. And again, we're trying to figure out what is the equation for spring energy. I can calculate spring energy using force times distance. I wonder how I use my graph. What part of the graph? Is it the slope of the graph? Is it the area of the graph? How will I find force times distance from my graph? That's the first thing, because that tells me work done. And then I wonder, what is actually my equation for spring energy? How can I find spring energy from this graph, and what does the equation shake out to be? As always, if you have questions, you drop it in the comments. You ask me in class. You send me an email. Until next time, see ya!